Hi, welcome to Theme 3. I've called this the magic of minerals because minerals are perhaps some of the most beautiful things we study in geology, and they're a key part of understanding how the Earth works, really getting down to pretty much its fundamental level. Now, minerals are, I suppose, the building blocks of rock. It's really important for us as geologists to be able to identify minerals. I suppose it's similar to learning to read. To learn to read, you need to be able to recognise words. To be able to read the rocks that we study, you need to be able to recognise the minerals that make up those rocks. Okay, we're going to start, as we always do, with a theme, with what's in a word. So what I'd like you to do is I'd like you to turn to the inside of the back cover of your Theme 3 booklet and have a go at, well, coming up with what do you think these words mean at the moment. Press pause now and give that a go. Okay, now I've had a go at what's in the word, let's start Theme 3. We're going to be working on page 2 of our booklet. Now, we can define minerals by this definition that I've shown you here. Okay, there are three key parts to this. They're substances that have a definite chemical composition. So minerals are a collection of a very specific set of elements. Each mineral will have a different chemical composition. Those elements are put together in a very specific way, what we call its atomic structure. Those two features then, this distinct chemical composition and its distinct structure, give the mineral a whole set of key identifiable properties. You can see from the image here different colours, different shapes. Okay, there are other properties as well that we'll get into a little bit later in the topic. The final part of our definition is that they're formed by inorganic processes of nature, so they're not created by living things. Okay. This is the periodic table of the elements. This is, if you like, our recipe card, our ingredients for the Earth. Now, as geologists, we perhaps don't look at this in the same way that the chemists do. There's a number of these elements, for example, we are not interested in. Let's get rid of those. Those are the elements that don't occur naturally on Earth. There are some elements as well that we are more interested in than others. Let me show you what they are. So we have oxygen, silicon, aluminium, iron, calcium, sodium, potassium, and magnesium. Those elements in particular are of interest to us as geologists. Let's focus on those for a little while. So let's get rid of the rest of the periodic table just for the moment. This is what I like to call the Big Eight. Let's just sort these out for us. Okay, so I've put those elements now into order, and that order is of their abundance within the crust. Okay, I'm just going to focus on the crust for this exercise. We'll worry about the deep earth another time. But in the crust, these 8 elements are the most common. If you look at the abundance of them, perhaps surprisingly, oxygen is the highest. Oxygen makes up nearly 50% of the crust. And remember, we're talking about the crust here, not the atmosphere. So these different percentages then show us how the crust is made up. If we add these together, we see something fairly remarkable. All of those elements added together make up 99% of the Earth's crust. That's massively significant. Why do you think that's so important for us as geologists? It also begs some other questions. We'll come back to the Big Eight in a moment, but let's just think about the other 85 elements that we're interested in. So I've excluded the Big Eight, and then we look at all the rest. Some interesting things in here. There's also some really important things in here. If you look at all these elements, we use an awful lot of these elements in things that we take for granted. For example, copper is in the other 85, zinc, nickel, chromium, titanium, really important, molybdenum, tungsten, gold, iridium. All of these are metals that we use a lot of. You know, we need these things. Most of the elements on that you can see here are useful to us. The mobile phones that most of you have will contain comfortably over 40 of these elements. The lithium, which is in this other 85, that is becoming increasingly important for batteries, not just for your devices, but perhaps for things like electric cars. So all these other 85 elements are actually really important. Yet we've just seen that 99% of the crust is made of the Big Eight, which means that all of those elements put together only constitute 1%. It's one of the reasons that the world needs geologists, because we need the stuff that's on this list, that we need these other 85 elements, yet cumulatively they only make up 1% of the crust. So individual elements can make up a tiny proportion of the crust. It makes them very difficult to find. We'll come back to how we actually go about finding these things later in the topic. Let's go back to the Big Eight. What I'd like you to do is I'd like you to plot a pie chart on page 2 of your booklet, ideally with a protractor or an angle measurer, although I realise at the moment that might not be possible. You may have to estimate it in a little bit. And I would like you, plot me a pie chart to show how the crust is made up. Okay, we've got the Big Eight there, but don't forget the other 85. Press pause now and have a go at that. Once you've done your pie chart, have a go at the questions on page 2. I apologise that I made a mistake with the questions. You'll see that 2 questions are identical. Don't worry about that. I'm sorry about that. Okay, have a go at that now. Okay, let's see what we've come up with. When you plotted your pie chart, it should look something like this. With the vast majority of our pie chart being oxygen and silicon, with the smaller, or with the other 6 elements of the Big Eight making up virtually all the rest of the pie chart, and finally that tiny sliver of all the other elements, a tiny 1%. With question B then, I ask you to work out what percentage the big two are. Sorry about the mistake with the questions, but it's about 75% of the crust is a combination of silicon and oxygen. And you actually find those together. They're bonded to each other. The most common form we see that is in quartz, which is actually the image you can see on this slide. Question 3 asks you what all the other elements are. They're all metals. Those of you that had to go at the digging deeper to think about the wider significance of this, I think the wider significance is in that 1%. The number of important and valuable elements that we need for our civilization. Copper, for example. You know, the copper we use for water pipes, for electricity cables. Imagine life without that. The fact they occur in such small quantities within the crust makes them tricky to find, and tricky to find in concentration. It's why we as geologists need to be good at what we do to be able to locate this stuff. Okay, as we have a look at the sunset from the International Space Station, looking down on the crust, this interesting split of elements that make up the crust has big implications for us as geologists. Not just in finding the elements that we need, but if we think about those big 8 elements, that means that the most of the rocks, most of the minerals, most of the rocks that make up the crust are made up of a combination of those 8 elements. What we need to do next time then is start to look at how those elements, when they're put together differently, create very different minerals and how we can actually tell them apart. I'll see you then.